In this lab, I want to demonstrate how to create a prismatic joint. So we could put in the two parts into an assembly, and we could put a contact set on those two parts and then activate the contact solver. And when we drag this over, it stops when it comes in contact there, and when we come in contact over here. But we don't get any physical dynamics in the assembly environment. It's always a good idea to turn off the contact solver once you have tested out the contact sets. So I'll go to dynamic simulation, and then I've set up a 2D contact on this like we did with the revolution joint. And similar to the revolution joint, there is 1 degree of freedom, except instead of being a revolve, it is a prismatic or straight line motion. And again, we get a force vector on here. The further out we pull on that vector, the more force, and the direction of the force determined by the direction of the vector. And we'll see in this lab too also how to adjust the amount of bounce that occurs when we come in contact between the two parts. If I go to that prismatic joint and I go to the properties of the prismatic joint, we see that it has 1 degree of freedom, and the T stands for translation. So it has 1 degree of freedom, a translational degree of freedom. And then we'll adjust some of these other settings in later labs. So let's look at how to set this up. And again, I'm going to start from a very basic beginning, and we'll work our way up to more complex problems as we go along. So I'll start a new part file, and then I'm going to start a new sketch on the XY or the front plane. I will draw a center point rectangle, and I'm going to make the width of this rectangle 3 inches, and I'll make the height of it 1.5. Then I'm going to draw a second rectangle, and I will make the width of this rectangle as 2 inches, and I will make the height of this rectangle as 0.75. My sketches are fully defined. I will do an extrusion. I'm going to extrude this area. I'll do symmetric, and I'm going to go a distance of 4 inches. Then I'm going to go around to the right side view, and I'm going to start a new sketch on the YZ plane, and I will draw a rectangle, and this time I'll do a 2-point rectangle, and I'll put this rectangle out here in space initially. Now, if you can't see the sketch through your part, underneath Tools, Application Options, on the Sketch tab, down here, Opacity of Sketch displayed through the shaded model, increase that up so that you can see that through the model. Otherwise it will disappear. You could also hit F7 for slice graphics, and that would also allow you to see through the model. And I'll go back to my sketch, and I'll do coincident the midpoint of this bottom line on the rectangle to this point right here. I'm also going to do coincident this point to the top of the part, and then I'll dimension the distance from here over to here, and let's do that dimension as 2.75. I'll then do an extrude cut through all. So I'll do extrude. I'll tell it to do cut midplane through all. I'll say OK to that. I then want to fillet the part, and so I'll do fillet, and I will do 0.0625, and I'm going to select the all fillets, all rounds, and we'll say OK to that. Let's go ahead and save this part, and so I'm going to call this part Prism Lock. Let's change the color of this part. I'm going to do this as blue wall paint glossy, and I'll save my file again. I will then save a copy of this file, so I'll do save as, and I'm going to call this one Prism Latch. Make sure now that you are editing your Prism Latch and not the Prism Lock. I'm going to change the color of this one to yellow. You can make it whatever color you like. And I'm going to drag the end of part marker up underneath extrude 1, and I'm going to edit that feature for extrude 1. So I'll say edit feature, and I'm going to control unselect this area, and then I'll select this area in here, and I'm going to change that distance then to 6 inches. I want to add or allow a little bit of clearance between the parts, so let's edit that sketch as well. So I'm going to edit the sketch. So this was the same sketch that we used to make the mating part. I'm going to subtract 5 thousandths from this, so I'll do minus 0.005 in for this one, and I'll do minus 0.005 for this one. So I've added 5 thousandths clearance. I'll then drag my end of part marker down. I'm going to edit this sketch. I'll delete this line. When we see a magenta line, magenta or pink, that means that geometry is sick. I'm going to delete that. We changed the previous geometry, and I'm going to change this rectangle as well. I think I'll delete the coincident constraint, and now I can move this rectangle around. I'll delete this point, and it might have been easier just to create this rectangle over again, but I just want to make sure that we see clearly how to do some various steps. I'll do project geometry, and I'll project the center point again, and this time I'm going to do coincident this corner to the center point, and I might hit F7 to go to slice graphics. And instead of this being 2.75, I'm going to put that in as a diameter dimension. So I'm going to right click on this line and change that to a center line, and then I'll do a diameter dimension of 0.25. Then I'm going to dimension the height of this as 1.75. I have a rectangle, 0.25 diameter, height 0.175. I'm going to draw a circle on this line, but not down here at the midpoint. On this line, say from about right here up to about right there. I'm then going to trim away this portion of the circle and this portion and this portion, so I'm just left with this half of it over here, and I will dimension that as 0.25. I will then do a revolve, but before I do a revolve, let's finish this sketch and delete the extrusion. I don't want to delete the sketch, so make sure you uncheck so that it doesn't delete the sketch. And I'm going to do another sketch on the right side plane, the YZ plane, and I'll project geometry, this line and this line, into the new sketch, and then I'm going to draw a circle at the midpoint of this line. And actually I might want to put it at a particular location, so let's just put it up here and then over tangent to this line, and I'll change those two lines to projected lines. Now remember, if I hide sketch 1 or sketch 2, we're now on sketch 3, so we project these two lines from sketch 2, and I've drawn this circle. Now I want to put that in at a particular height. If I turn on the visibility of sketch number 1, I want this circle somewhere in between here and here. So I just put it in by eye. I'll turn off the visibility now of sketch 1, and then I'll put in that dimension for the height. So I'll dimension from here up to here, and let's do that as 0.5625. That sketch turns fully defined. Now I'm going to right click and turn off the visibility of that sketch for now. We don't need it. And I'll turn on the visibility of sketch number 2, and then we'll do a revolve. I'm going to revolve this area and this area about this axis. And so it gives us an error. It doesn't like that circle being on the other side. So I'm going to edit that sketch, and I will bring this circle back around the other side. So I'll go ahead and do extend and bring that circle, and it doesn't want to extend. There we go. Okay, so I extend that back around, and hopefully we can get that back to a circle, and then I'll trim off this side. All right, now we'll try to do that revolve again. So I'll do revolve, and I want this area, this area. Now I don't want that corner up in there, and I want that area, and I want that, and now it accepts that. I will drag my end of part marker down for the fillets, and we see that it puts all of the fillets on here, and we will save this part. Then we'll create a new assembly, and so I'll do a new assembly. I will place the two parts, so I'll place from the prismatic joint, I'll place the lock. I want this grounded at the origin, so I'll right click, place grounded at origin, then hit escape, and then I'll do place, and I'll get the latch, and I'll just click someplace in space to place that latch. Then we'll save our assembly as prismatic joint. Now recall that we allowed some clearance between these parts, so this part is slightly smaller than this hole. In the real world, this face would come in contact with the bottom of that, or the bottom face here would come into contact here, and one side in contact here or over here. In the CAD world, we can use the origin planes to constrain the parts, and that will pay off with a lot of dividends in various things that we do going forward. So whenever possible, I use the origin planes to constrain my parts. So I'll do constrain. I'm going to put it on flush, and I'm going to constrain the YZ plane of the prism lock to the YZ plane of the latch. And then I will do the XZ plane of the lock to the XZ plane of the latch. When I do that, now my part is constrained with one remaining degree of freedom, a translational degree of freedom that we would expect. Now right now it goes right through that part, but if we add those to contact sets, then we see that it will stop when it comes in contact here and here. And I don't know if we'll be able to see this, but I did allow a little bit of clearance in between the blue part and the yellow part so that it can slide back and forth. Remember, we can't make perfect parts in the real world, so we need to allow a little bit of clearance so that they can in fact move. And even if we could make perfect parts, there would be so much friction between these two parts that you wouldn't be able to move them back and forth. We'll then go to dynamic simulation, and Inventor automatically converted our assembly constraints into prismatic joints. So if I test it here, again, it only moves back and forth, but right now it will go right through the part. We'll take care of that in a moment. So we automatically had the assembly constraints converted to a dynamic simulation joint, but let's assume that we wanted to do this manually. Again, if we go into insert joints, you're not going to see all the possible joints that you can apply unless you turn off the automatic conversion. So let's go to the simulation settings. I'm going to turn off the automatically convert constraints. Notice right now the latch is in the mobile group, the lock is in the grounded group. I'm going to turn this off, and I'm going to tell it no, I don't want to keep that prismatic joint. Normally we would say yes. I'll say no, I'll say okay. It moves both of those parts into the grounded group. I then want to insert manually that prismatic joint. So there are some occasions where you will want to manually put in your joint. So I'll select the prismatic joint. Now you can get these, rather than opening up this table, you can get these joints by this drop down list once you know what the names of them are. Now it asked me to select a Z-axis for this part, for component number 1 and component number 2. But there isn't anything convenient right here to select as a Z-axis. If I select, for example, this is my Z-axis for component 1, and then I select, say, this is a Z-axis, and I say apply to that, it's going to move those two axes together, and that isn't what I want. So I'm going to undo that, and we'll do it a different way. So I'll do the prismatic joint again, but this time, instead of looking at this in the dynamic simulation view, I'm going to change this to the assembly view, and then I'll expand these origin folders, and so now I can select the Z-axis from this part, and then I'll go to the second component and I'll select the Z-axis from the second component. So we had to do that by going to either assembly or to modeling tree. If we go to modeling, we can see the same thing, except there's more detail. We only need to see those axes. We'll worry about these origins and these other settings later on. We do need to make sure that the X is lined up with X and Y is lined up with Y, but because we created these two parts in the same orientation, that is already set up by default. So we'll say OK to this, and again, so now we have that prismatic joint. If I come over here to the browser, I go back to dynamic simulation, we now have that prismatic joint. We entered it manually, and so there are actually 3 different ways to do this. There's an automatic way, there's a manual way, and then there's a semi-automatic method. We'll see the semi-automatic method in a future problem. So far we've seen automatic and a manual technique for entering that joint. And there are different situations where we'll need all three of those techniques to get the desired motion in our dynamic simulation. Now right now this part goes right through there, and we don't want that part to go through there. So I'm going to go back to the assembly environment, or let's just finish dynamic simulation for a moment, and I'm going to right click on this lock, the prism lock, and I'll do open. Now you might need to shift right click, put your selection priority on part priority, and if you do that you can either click on it here or you can click on it over here and we can open up that part. Let's expand extrusion number 2 and turn on the visibility of sketch number 2, but I want to turn off that dimension. We don't need to see that, so I'll turn off the dimension visibility. So think of this box right here as a fence, and think of that fence as going to infinity in the x positive and in the x negative direction. So we want to keep something inside of that fence. I'll then go to the other part. Let's go ahead and save this first, and then I'll go to the other part, and I will open up the latch, and on the latch we created this sketch number 3 with this circle in there. Again, I'm going to hide the dimension visibility. I don't need to see the dimension. So I want to keep this circle inside of that fence that we have on the other part. So this circle we want to keep inside of this box. So I'll go back to environments, dynamic simulation, and I will add a 2D contact then. So I'll do insert joint, and I can go to here to find the 2D contact, or I can just get from the drop down list a 2D contact. And so it asks me to select a curve. I'm going to select one of the lines on this box. Be careful you don't get this yellow one up here because it doesn't form an enclosed area, only these white lines. So I'll select this line on this box. Now that box has an inside and an outside, so we could keep something out of the box or we could keep it in the box. In this case we want to keep it in the box, so I need to flip that Z to the other direction. So I'll flip the Z, so now the three-headed arrow, or the Z, is pointing inside the box, and then I'll go to the second curve and I'll select this circle. Now I might have trouble getting that unless I do the select other, and then I can go and get that curve, and then I want this, the outside of this circle, to stay in that box, so the Z is pointing in the correct direction. If I wanted to treat this as a whole, I would want the Z pointing towards the inside of that circle. I'll say OK to that, and now if I drag this, we see that it stops when that circle contacts that box over there, and it stops when it contacts the box over here. We can turn off the visibility of these sketches, and so on the View tab, if I go to Object Visibility, I'll turn off the visibility to 2D sketches, but everything still works even though we don't have it visible. Let's look at controlling the amount of that bounce. So I'm going to go over to 2D contact. I'll expand the contacts and right click on 2D contact, and I'll go to Properties, and notice that there is a restitution value and there is a friction value. Think of this restitution. Imagine that I had a bowling ball and I dropped it straight down onto the floor. If I have the restitution on 0.8, if I'm dropping it, say, from a height of 3 feet, it's going to bounce back up 80% of that 3 feet. Or if I put it on 0.5, it's going to bounce up halfway of whatever height I drop it from. If I don't want it to bounce at all, I put it on 0. The amount of bounce between the parts are depending on the material that the parts are made out of. So if I have that bowling ball, if I drop it on a carpeted floor, it's going to bounce a different amount than if I drop it on a concrete floor or if I drop it on a wood floor. And these values would be determined by doing some physical experiments and recording the results of the experiments. So there may be somewhere on the internet a place to look up some relative values, but normally you would have to do some experiments to figure out what should be the appropriate value. Or from experience, you can guesstimate what would be the appropriate value for the restitution. We'll leave friction as what it is for now. Okay, so if I put that restitution on 0, now when I drag this over, when it comes in contact, it just stops. When it comes in contact over here, it just stops. It doesn't bounce. And so we need to adjust that restitution to an appropriate value for our properties, our material properties. And now, so I have just a little bit of bounce on this. And now again, if I go too fast, I can end up outside of the valid location because the computer can't keep up with the calculations. And sometimes if you get outside of it, I'm trying to get outside, you can't get back inside. Okay, so I'm going to leave it out here, and if I try to get back inside, it gives me an error that it says it can't get back inside. So I have two choices. I can either delete that and put it in again, or I could undo back to where it was in a valid condition. A lot of times though, you're going to end up with a complicated assembly where the best way is to temporarily suppress that joint, move it back into a valid position, and then unsuppress to make it active again. And so now it's back inside the grounded part. So that is a translational constraint with 1 degree of freedom and 2D contact with the restitution